Continuing to work on solving logarithmic equations using the one-to-one property. Oh, well, let's see. We got about 3 examples we're going to work through here. And the first one is -3 of the natural log of x equals -24. Well, -3 times. Well, let's divide both sides by -3 to start with here. And then that would leave us with the ln of x, natural log of x, equals -24 divided by -3 is 8. Now, I can exponentiate both, and I would need to do it to both sides, because we know algebraically what we do to one side of the equality, we've got to do to the other. But if I do that, then I can cancel out this natural log. So let's say we got e raised to the power of ln of x is now equal to the natural base of 8. And the ln and the e cancel out, leaves us with x is equal to e raised to the power of 8, and that might even be a permissible answer. But let's just go and kind of calculate that. And I'm not going to use the calculator here on the video, but I'm going to kind of talk my way through it. So I'm going to hit second ln, which brings up e raised to the power of something, and I'm going to put in 8. And then I'm going to hit enter. And if I just round that to the nearest whole number, e to the 8th then is approximately equal to 2,981. I encourage you to put that calculation, e raised to the power of 8, in your calculator and confirm that I've given you the correct answer. Let's look at one more. All right, here we got 4 minus, or 4 -3 log of 5x equals 16. Well, I got that positive 4 out there, so why don't we subtract 4 from both sides as we begin. Then I've got -3 log of 5x equals 16 minus 4 is 12. And then we got this -3 times, which is actually, we know, is just an exponent of the log. But I can go ahead and divide that by -3. And then when I do, I've got the log of 5x equals -4. Now, I'm dealing with a common log, and a common log is log base 10. So let's exponentiate this using the 10. So then I got 10 times the log of 5x equals 10 raised to the -4th power. And the 10 and the common log cancel out. And so now I've got 5x equals 10 to the -4th power. And I'm going to save calculating that until after I divide both sides by 5, so that x equals 10 raised to the -4th power divided by 5. And let's see what we got here. So here again, I'm going to hit second log, because that's going to give me 10 raised to a power, and I'm going to put in -4, being careful not to use the subtraction button, divided by 5. And I get 2 times e to the -5th power. So let's see if I were to write that out. Then that equals 0. And I move that decimal 5 places, ending with a 2. 1, 2, 3, 4, 2. Shazam. That's a pretty small number. 10,000. 2 100ths. How about that? Now, since I've been having so much fun, I just feel like I need to do at least one more. All right, now this one's a little bit different. Log base 3 of x squared minus 1 equals 4. Well, you know what? I'm going to exponentiate again. So I'm going to have 3 times log base 3 of x squared minus 1 equals 3 to the 4th power. Again, what I do to one side, as long as I do it to the other, I'm operating in correct form. And so the base 3 and the log of 3 cancel out. And so then we got x squared minus 1 equals, let's see, 3 to the 4th power is 81. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. And shall we add 1 to both sides? Sure we should. We got x equals now 82. X squared, excuse me, equals 82. Then let's take the square root of both sides, and so that x is equal to plus or minus the square root of 82. And let's see, what would be the square root of 82? I think it'd probably be approximate. So again, I'm going to hit second, where that square root button is, which is x squared, second x squared, put in 82. Hit the enter, and it is going to be, let's see, let's round this to the nearest hundredth. Plus or minus, don't forget to plus or minus, 9.06. And again, let me encourage you to take your calculator, go through the final calculations, make sure you're coming up with the right number. Then you know you got your keystrokes down if you have any doubt about that. Moving forward.